ఒకసారి తొందర చేసేస్తే 20 minutes అయిపోతుంది. Hello students, I am going to explain about a very important problem faced at the time of development of kinetic theory of gases. Kinetic theory of gases. The kinetic theory of gases, the theory and the beginning step for the kinetic theory of gases was the experimental results published by Gay Lussac in the year 1808. Okay, I am just I am going to explain how the kinetic theory of gases was started. Remember that ancient people knew only about 11 elements. 11 elements, most of them are metals like gold, silver, iron, copper, tin, mercury. Like that, they knew only 11 elements, ancient, up to 1000 AD. After 1000 AD, some 3 or 4 elements again added. So by 1770, we knew only some 20 elements or 22 elements like that. And suddenly the scientists shown interest about the vapors releasing during chemical reactions. Okay, previously also when chemists were doing chemical reactions, many vapors were releasing, but those vapors were neglected because all chemists thought that those vapors belong to air, and so they neglected. But from 1770 onwards, chemists paid special attention on the release of vapors. The result was the discovery of hydrogen in the year 1776, the discovery of oxygen in 1774. Okay, once hydrogen and oxygen were discovered, chemists were started to conduct many experiments on hydrogen and oxygen, and so many experimental results were published. And so some of the theoretical chemist, the task of theoretical chemist was to give proper explanation for the results of those experiments. And see, let us consider one of the scientists, say Gay Lussac of French. He was a French chemist, and he in the year 1808 he published a result of his experiment. According to that publication, we see that 2 volumes of hydrogen. See that 2 volumes of hydrogen plus 1 volume of when 2 volumes of hydrogen, when it is combined with 1 volume of oxygen, the result was 2 volumes of water. Usually we generally think that when 2 volumes of hydrogen and 1 volume of oxygen is combined, we should get 3 volumes of water. But surprisingly, Gay Lussac observed that 2 volumes of hydrogen plus 1 volume of oxygen is producing 2 volumes of water, and so the ratio is 2:1:2. It is a surprising result and a very challenging problem for the chemist of the year 1808. At that time, see that Gay Lussac conducted he had taken different volumes. He took 3 volumes of hydrogen and 2 volumes of oxygen and still got 2 volumes of water, as shown below. See that. Gay Lussac also took 3 volumes of hydrogen and 2 volumes of oxygen in one container, and he carried chemical reaction. After chemical reaction, he observed 2 volumes of water, but 1 volume of oxygen and 1 volume of oxygen left over. Here again he observed that 2 volumes of hydrogen is only utilized and 1 volume of oxygen is only utilized in making 2 volumes of water. Remaining is left over. Like that, even though he had taken different volumes, every time he observed that only 2 volumes of hydrogen is combining with 1 volume of oxygen, and so he got fixed ratio, that is 1:2:1. Okay, it has become very difficult for the chemist of that period to explain those results. See that actually in 1803 AD, Dalton realized that matter is made up with atoms. How? I told you that oxygen discovered in 1774 AD, hydrogen in 1766 AD. Once these gases are discovered, many experiments were conducted using gases, many experimental results were published, and so the task of chemist was to give proper explanation for those results, and Dalton was prominent one, and he did so much work to explain the results, and finally he thought that unless matter is made up with atoms, it is very difficult to explain those results. So according to him, if only by making the assumption that matter is made up with atoms, then only by that assumption it is possible to explain the results of those experiments. That is the idea of Dalton, and that idea was struck to him in the year 1903, and he published his results in 1808 AD. So atomic theory of Dalton proposed in the year 1808, even though he got that idea in 1803, and he worked on that idea for about 5 years and published his results in 1803 AD. In the same year, our Gay Lussac also published his results on gas and oxygen gas and hydrogen gas. So now there are two groups. Dalton and Dalton supporters is one group, and rest of the chemists was another group. But Dalton also proposed wonderful theory that matter is made up with atoms. He did one mistake. Dalton said that same kind of atoms will not combine. That is the idea held by Dalton. According to Dalton, same kind of atoms means say two hydrogen atoms will not combine. According to Dalton, between similar atoms there will be repulsive force. Therefore, two similar atoms, same kind of atoms will never combine because of this repulsive force. And the Dalton supporters also accepted his theory blindly. And so Dalton and his supporters failed to explain Gay Lussac theory. Okay, but they blamed Gay Lussac that he conducted his experiment with some mistakes, and so he got wrong results. Like that, they blamed Gay Lussac, and simply they said the Gay Lussac had not done his experiment properly, and there were some mistakes in the collection of data, etc. And so Gay Lussac is coming with wrong data. Like that, they blamed Gay Lussac. Gay Lussac gave one important conclusion. He said that his experiment is always providing a ratio of simple integers like 2:1:2, but never it is like 2:1.317:2. So he concluded that always atoms are combining with other atoms. In other words, atom is not going to divide and appear as 1/2 atom or 0.37 atom or 0.25 atoms. Like that, atoms are not going to appear. They always appear as integer multiples, 1 atom or 2 atom or 3 atom, like that. That is why he is getting every time the ratio of reactants to products to be 2:1:2 because the atoms are combining as atoms without any division. So in this way, Gay Lussac supported the idea of Dalton that atom is indivisible. Atom is not going to available as 1/2 atom or 1.2 atom, like that. Just like a person is not going to appear as 1.2%, 1.3% or 1% or 2%, like that only. Like that, atoms also appear as one atom or 2 atom, like that. So by repeatedly getting 2:1:2 in various values, Gay Lussac confirmed that matter was made up with atoms and supported the idea of Dalton. See, Gay Lussac supported atom, but Dalton blamed Gay Lussac. That is surprising thing. And many tried to explain the results of Gay Lussac, and all they failed. The reason was all they assumed that same atoms would never combine. Okay, many chemists of that time failed to explain the Gay Lussac. That is the reason was many assumed that the same kind of atoms will never combine. By that wrong assumptions, they could not able to explain the results of Gay Lussac. Then in the year 1811 AD, Avogadro, an Italian scientist working in small town called Turin. Turin was a very small town in Italy, and which was very far away from the big scientific centers of Paris, London and Berlin. And Avogadro was working in that small town called Turin. He came up with brilliant explanation for the results of Gay Lussac. Avogadro came up with the idea that hydrogen gas and oxygen gases are diatomic. That is, hydrogen appears as H2 and oxygen appears as O2. Remember that even in 1808, scientists were assuming that water formula to be HO, not H2O. Why not H2O? Because the same kind of atoms will never combine. That is why, according to them, water formula to be HO. Avogadro confirmed that only by assuming hydrogen and oxygen gases were diatomic, then only it was possible to explain the results of Gay Lussac. Avogadro said as the space between the particles was large in gases, it was possible for us to see the cases shown below. See that now you see the two chambers. Avogadro took two chambers. One is chamber 1, another one is chamber 2. The chamber 1 is containing gas 1 and chamber 2 is containing gas 2. Gas 1 is containing gas particles. Each gas particle is made up with single atom. Gas 2 is containing gas particles. Each gas particle is containing 3 atoms. See that. And the gas particles of gas 1 is containing is made up with single atom. Particles of gas 2 is made up with 3 atoms. See that there are 12 atoms, 12 gas particles in gas 1. There are 12 particles. There are 12 particles in gas 2. There are 12 particles in gas 2. Both gas 1 and gas 2 are occupying same volumes. Both gas 1 and gas 2 are occupying same volume, and both are containing same number of gas particles. See that even though gas 1 is made up with a single atom, gas 2 is made up with 3 atoms. Gas 1 and gas 2 are containing same number of gas particles. See that you should see the difference between particle and atom. Gas 1 particle is made up with single atom. Gas 2 particle is made up with 3 atoms. The 3 atoms combined together is called gas 2 particle. A single atom is said to be gas 1 particle. See that. Why it is possible to contain same number of gas particles is the space between the atoms is large. The space between the atoms is large. Therefore, at the position of the single atom, you can also place some more atoms. Even if you place some more atoms, there is no problem with gas particle 2 and gas particle 3. Therefore, it is possible for the gas particle to be made up with a single atom or multiple atoms. Even then, all the gas particles will occupy same volume. In the chamber 1, you have 12 gas particles. In chamber 2, there are 12 gas particles, even though gas 2 particle is made up with 3 atoms. And so Avogadro came up with a wonderful idea that gases occupy same volume and contain gases occupying same volume contain same number of gas particles at a given temperature and pressure. At a given temperature and pressure, equal volumes of gases contain equal number of gas particles. This is one of the important idea of Avogadro. Using this idea, our stoichiometric chemistry is all going on. Okay, this was proposed by Avogadro in the year 1811 AD. Here a question will arise. When we see the particles of some same gases made up, okay, this is already explained. Then how it is possible for all gases to contain same number of particles? This is also explained. And now we see how Avogadro explained the experimental result of Gay Lussac. Here, Gay Lussac result is that 2 volumes of hydrogen combined with 1 volume of oxygen will produce 2 volumes of water. So instead of volumes, I am taking 2 H2 molecules. 2 volumes of hydrogen in place of 2 volumes of hydrogen, I am using 2 H2 molecules. In place of 1 volume of oxygen, I am using 1 O2 molecule. Then let us see how this experiment is producing 2 water molecules. See, to combine 2 H2 molecules with 1 O2 molecule, you have to apply heat energy. Most of the chemical reactions will be carried under the action of heat. By heat action only, many chemical reactions will be carried. Even in our body also, because of heat energy, many chemical reactions are going on, and hence our body temperature is 37 centigrade. Okay, that once heat is applied, the 2 H2 molecules are separated into 4 H molecules. 2 H2 molecules are separated into 4 H molecules. 1 O2 molecule is separated into 2 oxygen molecules, 2 oxygen atoms. 2 H2 molecules are separated into 4 hydrogen atoms. 1 O2 molecule is separated into 2 oxygen atoms. Then what will happen is the 2 hydrogen atoms will combine with 1 oxygen atom. See that these 2 hydrogen atoms are combining with this oxygen atom to produce 1 water molecule, and again these 2 H atoms are combining with these oxygen atoms to produce another water molecule. In this way, 2 H2 molecules when combined with 1 O2 molecules, the result is 2 water molecules. In this way, Avogadro explained clearly the experimental result of Gay Lussac. But Dalton and other scientists scientists rejected ideas of Avogadro, because Avogadro used the idea that two similar kind of atoms can exist and form diatomic, like H2 and O2, and that diatomic concept was unacceptable to Dalton, and so he rejected that idea. Next, at the same time, in the year 1812, another scientist came. His name was Berzelius. Berzelius was famous for his experiments on using electricity, electrolysis experiments. In the electrolysis experiments, he explained the reason. Using his electrolysis experiment, he gave the reason why sodium chloride is formed. Using electrolysis experiments, he confirmed that sodium atom is going to become positive ion and chlorine atom is going to become negative ion, and so there is a attraction force between sodium and negative, and so sodium chloride is formed. And also he had given another explanation that two chlorine atoms will not combine, because a chlorine atom is containing negative charge, another chlorine atom also can contain negative charge. Between two negative charges there will be repulsive force, and so two chlorine atoms will not combine. That was the idea of Berzelius, and Berzelius was also influential person, because his ionic theory explained the actions of acids and bases in the year 1812. Remember that by the time of 1812 there was no idea about electron, there was no idea about covalent bond. Only ionic bond theory was just emerged. There was no idea about covalent bond. Covalent bond was introduced in the year 1916, 100 years later. Electron was discovered in 1897. Only they were not considering charges as in terms of electrons, but they simply, in the macroscopic point of view, they were considering some charges are positive, some charges are negative. Like when glass rod is rubbed with silk, glass rod becomes positive charge, and silk becomes negative, like that. Okay. Electron was discovered in 1997, and the covalent bond theory was introduced in 1960. So these two prominent scientists, Dalton and Berzelius, in 1812 strongly rejected Avogadro, and so Avogadro theory was not considered by many as seriously. Avogadro theory was not considered seriously by many chemists. Okay, once when Avogadro theory, even though Avogadro theory was correct, it was rejected. The result was very tremendous bad effect on chemistry, because the chemist at that time many new elements were going to be introduced in chemistry, and chemists were struggling to determine the atomic masses correctly. The one scientist will come up with one value of atomic mass, but another scientist come up with another atomic mass value. Thereby there was a lot of confusion in the chemistry. All the confusion in the chemistry was due to the reason that many believed that same kind of atoms will not combine. Because of this wrong idea, because of the support of the wrong idea, they were unable to determine atomic masses correctly. That confusion continued for about 50 years. For about 50 years. Only in 1858 a reasonable solution was found for the determination of atomic masses once Avogadro idea was accepted. For example, Stanislao Cannizzaro, an Italian scientist, irritated very much by the confusing atomic masses proposed by various chemists for the past 50 years. And in the year 1858, he himself accepted Avogadro principles and invented procedures to determine the atomic masses. By these procedures, he determined atomic masses correctly for various atoms in different ways. Even though he followed different methods, every time he is coming with correct value of atomic mass for many known elements of that time. So he was convinced that his idea was correct, and so he published his results in Italian language. But at that time, the dominant scientific languages were the languages that are dominant in scientific world were French, English, German. But Cannizzaro published his results in Italian, and so the results were not reached to many wide circles of scientific community. Then what happened is, then 2 years later, that is after 1858, that is in the year 1860, first international conference of chemistry was conducted in a small German town called Karlsruhe in the year 1860 from September 3rd to 5th, a 3 days conference, first international conference on chemistry. The conference purpose is to propose a correct method for determining atomic masses. But even though the conference was conducted for 3 days, even on the last day, the scientists were not reaching a general agreement on the determination of atomic masses. Then Kenijaro distributed his ideas, distributed his pamphlets published in French, German, and English. And so many scientists were convinced about the results of Kenijaro, and they all surprised by the wonderful results of the Kenijaro. And among them, the two prominent scientists were Lothar Meyer of Germany and Mendeleev of Russia. And these two chemists were very happy because after finding a correct method of determining atomic masses, they came up with periodic tables for chemical elements based on atomic masses. The year is 1860. Remember that even in the year 1860 there was no idea about electron. Electron was discovered in 1897, and covalent bond theory was introduced in 1916. But periodic table was introduced in 1860 by Mendeleev based on atomic masses, and its table was a very big table, elaborate table, and the table brought revolution in the chemistry. And finally in the 1916 we came up with a new atomic table based on atomic mass, that is what is called modern atomic table. Okay, this is all about Gay Lussac experiment, and from this story you see that even though great scientists contribute for the development of science, but unfortunately they also contribute for the backward development of science because of their negligence. The examples are Berzelius and Dalton. Okay, I stopped this video, and next I came up with a new video later. Thank you.